Welcome to Learnpedia, the ultimate JEE and NEET prep tool currently being used by more than 20,000 aspirants. Let's see if you can answer this actual JEE question. If you think you got the answer, post it in the comment section below. To understand the concept behind this question, go ahead and watch this full video.
Let's understand a very important concept, Hess Law of constant heat summation. You had already learned in chemical bonding while calculating lattice energy, and let us revise here again. What is this Hess Law? It states that the enthalpy change taking during the process depends only on the initial and final states and independent of the path by which the process is carried out. Means the enthalpy changes are same whether a chemical reaction takes place in one step or through several steps. For example, when we take a general equation where A is converting into D, and in this particular process the enthalpy change is equal to Q kilojoules. And if the same process is carried out in a different method in stepwise, like A giving rise to B, then B giving rise to C, then C giving rise to D, where the enthalpy changes in all these three individual steps are Q1, Q2 and Q3 respectively. So let me write this as H1, H2 and H3. And according to Hess law, the energy changes are same whether a chemical reaction takes place in one step or through several steps. So that is the reason why this capital Q, this Q is equal to Q1 plus Q2 plus Q3. This is a general example. So let me take a specific chemical reaction. Let us take the formation of carbon dioxide in one step. That is, this solid carbon when heated in oxygen, this results in the formation of carbon dioxide gas. And in this particular process, the amount of heat released is equal to 94 kilocalories. Now if the same reaction is carried out in two steps, it is like this. First, carbon is converted into carbon monoxide, and then that carbon monoxide on further combustion, that is converted into carbon dioxide. And the enthalpy change involved in the first step is equal to minus 26.4 kilocalories, and in the second step it is equal to minus 67.6 kilocalories. So now according to Hess law, the enthalpy changes are same whether a chemical reaction takes place in one step or through several steps. If we take this one as delta H1 and delta H2, so both these values becomes the same because the sum of these two values is equal to 94. So I repeat the statement, the enthalpy changes are same whether a chemical reaction takes place in one step or through several steps. Now let's see some important applications of Hess law. First one, we can find out the heat of reaction. Then we can also find out the heat of transition when one allotropic form is converted into another allotropic form. And we already know the meaning of heat of transition. We can also calculate the lattice energy, which we have done it in chemical bonding, isn't it? And we can also calculate the heat of formation of intermediate compounds which are unstable. If you can recollect, when carbon is converted into carbon dioxide directly in one step, the enthalpy change is minus 94 kilocalories. And when carbon is converted into carbon monoxide, and then when carbon monoxide is converted into carbon dioxide, we have two different steps. Suppose if you want to calculate the enthalpy change for carbon converting into carbon monoxide or the heat of formation of carbon monoxide, we can calculate from these two values, because we know how to calculate the combustion of carbon monoxide, which is equal to 67.6 kilocalories, and always it is not possible to calculate the formation of carbon monoxide, because when carbon is burnt in limited amount of oxygen, then only we get carbon monoxide, but there is every chance of formation of carbon dioxide. So whatever enthalpy change we get there, it might not be the exact value of formation of carbon monoxide. And as we know that delta H is equal to delta H1 plus delta H2. This is 1 and 2, and this value is minus 94, and we can easily get the value of this particular one, and which is nothing but 26.4. So in this way we can find out the heat of formation of the intermediate compounds which are unstable. That is about the Hess law of constant heat summation.
Hey there, hope you understood the concept. Here's the solution to the question asked at the beginning. You can check now. Found this video useful? Hit the like and share icons to enjoy more such videos. Use the comment section below to post your feedback, questions or queries. LearnPedia's JEE and NEET prep tools contain more than 4,000 videos and over 20,000 questions. These can be accessed online on our website or offline through an SD card or a pen drive. To buy now, visit www.learnpedia.in. You can also experience a free demo of our product before buying.